Welcome to Dreamforce. My name is Josh Kaplan. I will be taking you through how we compile Apex, what our compiler does, and a little bit of insight into the new compiler that we've been building for the Apex programming language. But before I start, I'm required by, I don't know what I'm required by, but I have to do this, forward-looking statements. I'm going to be talking about a brand new compiler that we're building. Please don't make any purchasing decisions based on forward-looking statements, only on currently available, publicly available information. Thank you very much. You can find this all online. It's a fun read. So some of you probably wonder sometimes, where does my code go? I click this button, I deploy via the tooling API, and where does it go? What happens? I used to wonder, before I was product manager, I was working in services here, and I was working as an Apex developer, working with our customers, writing code, and I often wondered the same thing, what really happens behind the scenes? So I'm going to take you through a little bit of backstage. What do we do when you actually save it? How do we operate? How do we use that and run your application? The basic operation, the highest level, is pretty simple. The class file that you provide to us, we save that into our database. We do then is we compile it into Java bytecode instructions. Now, Java bytecode instructions are operands used by the Java language to, used by most Java runtimes to execute your Java program. We chose to use the exact same instruction set for a variety of reasons. A lot of it's because it was compact, small, it's universally understood, so we could find people who could actually work with it on our team. This is what we do. We compile that Apex class you give us into these Java bytecode instructions. Now, I'm going to tell you right now that I don't know what goto means. I know what that is. I don't know what the rest of these are, so we're not going below that level. Java bytecode, you probably take a class or two on it if you want to learn more, but we're taking advantage of this open standard to run our application. And when we do run that application, we don't actually run them against the basic Java runtime. We run an interpreter. We interpret these instead of putting them directly on the metal. And the reason for that is real simple. It's safety. We can't let anyone access memory outside of their process or get a hold of anything that's not sandboxed to the transaction you're in. And in order to be safe, the best way for us to be safe is to interpret, do our own interpreter on top of these instructions and not run them directly against the Java toolkit. So we are running an interpreter on top of this. That's the basic operation. You save your file, we compile it into Java bytecodes, and then we interpret those bytecodes in our own way to make things safe, to make them multi-tenant, to make everyone happy, and nobody ever ends up with any problems of accidentally stealing someone else's data. Never the other way around. No one ever has their data, so you accidentally steal someone's data, right? So how does that really work though, right? That was a basic thing. That's if everyone has one computer and I'm sitting on my desktop. But in the real world, we're multi-tenant. We have a multi-tenant environment. The guy over there is working on one machine. His requests come on one of our app servers. There are 10 here in the diagram, and there's 30, 40, depending on with Sandbox here or whatever. There's different application servers, and the database is in a distinct place as well. So how does this work more in reality? Well, the database is where I am saving the file. That is still true. When I come and make a request, an Apex request that needs that particular class, and whether it's the trigger or the class, I'm going to request, I'm going to hit one of these app servers randomly. I'm going to be distributed to one of them. And I'm going to need access to that. So I'm going to ask the database for a compilation. It's going to compile the bytecodes, and I'm going to have that available to me locally on that particular application server. So I can now run whatever I needed to run. It's compiled. It's up on my machine. I'm happy. I'm ready to go. So different steps because we got different parts of the process here. Now, that would be pretty inefficient, right? Because if another request came into a different application server, they would also have to ask for a compilation to take place. I want to store these things, and I want to take care of these in the multi-tenant world such that your process doesn't compile on every single request, right? I can't just compile everything and throw it everywhere. You all write way too much code, so we need to do something else. What we do is we use a distributed cache to help us out. Without getting into too much detail, the distributed cache is a shared pool of memory from each of the application servers in the application pool that sits underneath all the application servers that can be accessed by all of them. So it looks something like this. Shared pool of memory beneath all the application servers. So instead of taking that compilation request and putting that up on my local app server, what I'm going to do instead, when I make the request, I'm going to compile it and I'm going to store it in the distributed cache. Well, this means that the next person who comes to access this particular file, who wants class ABC, they're not going to go back to the database and recompile it. They're going to have a compiled form with the Java bytecodes ready to run in that distributed memory space. Much faster, saves a lot of time. Compilation, some of your orgs are very complicated. They can take quite a while to compile. So once the compilation is done, every subsequent request will have access to the compiled thing. Way faster, right? So this is one of our optimizations that we do to make sure that operation goes smoothly and quickly. That is also not good enough. What we do in addition is when we want to run and interpret the bytecode, we have what we call the interpretable form of the bytecode. And we say we inflate that. So when your request comes in and you find that you've got this compiled form in the pool, it's going to bring an interpretable form into your app server memory, and it's going to run on that interpretable form. And it's going to keep it there. So I've got a cached copy up on my app server that I can access the next time. So my typical flow when I do make a request in the full real world is my request is redirected to one of these app servers, and I'm going to check in what we call level 1 cache. Do you have that inflated interpretable form ready to run? If so, great, let's go, let's do this. If not, let's go to the next step, level 2 cache, which is that distributed cache pool. Do you have a compiled form there for me already? If so, great, let's go. I'll inflate that, and we'll start running it again. And if that's missing, go to the database, compile the file, and move forward with it. So that is the actual flow of how things are going to be working in the full application system. So in the warm state, we've been running for a while, you haven't touched anything, everything's been sort of humming along. Every app server will have a copy of the inflated interpretable form of your class. There'll be a compiled form ready to be used down there in that second level distributed cache. And in fact, there's even a second copy, which we'll get to in a while, over in the database. So your request will come through looking for these things. And in the warm state, everything's populated and everything's good. So that there is what actually happens to your Apex class, and that's where it goes. Now, of course, you're going to make changes. You're going to change the way something works, and all of the things that you had cached before are no longer going to be compatible with the change that you've made. Many of you have experienced this with your iPhone plugs when they went to the change there. So when you do that, when you do a change that is going to and just deploy it to your system, all of the things that you had cached up, all that warm state is no longer warm. It's going to be cold. So we're going to fix that through on-demand recompilation. So someone goes and changes a file, and then immediately all those cache entries are invalid. You're back to a cold state again. So the next request that comes in is going to need to go check the level 1 cache. Nope, nothing there. Check the level 2 cache. Nope, nothing there. I'm going to have to recompile. I'm going to have to start over again and compile. We're not going to compile everything at once. We're just going to do it when you need that. What files do you need? If you need 3 files because they call one another, we're going to do 3 of them. If you need the whole of your org, we'll compile the whole of your org and we'll put it up into the next state. So my request will come in, as I said, misses L1, misses L2. It goes through and it makes a compile request, it compiles it there, and now I've got my interpretable form ready to go. So this is all good. This works pretty well. Some of you have very intricate orgs that do take a long period of time. So user number 1 pays the price. User number 1 takes the hit for everybody. So their request comes in and it needs to get 80% of the org recompiled after you've made a change. Their request is going to take a little bit longer, a few seconds. It's going to take some time. And then everybody else after that's going to be fine because we'll have compiled, we'll have done that step. So the first user is going to be taking a bit of a hit there. So keep that in mind. When you are making changes during business hours, the first person who comes in to take your changes, they're going to have to do this compilation process. Now, this can be a problem if you try to do something in the middle of the day. Lots of users are accessing the system, and lots of them need the exact same resources because everyone is going to try to compile the things that they need. So if I come in as the first user, I'm taking the hit because I'm the kind of guy I am, and so I'm going to make a compile request. That's taken a while, and while I'm doing that, more users come in, and more users say, I need the same thing. They're all going to make the same compilation request because they don't know that line is going. They don't know if what I'm compiling is going to be what they need, the full set of what they need, and they can't compile just a part of it. They need to compile everything that they need. So if you do something like a change in the middle of the day, everybody's going to be doing this exact same process, and everybody's compiling, and everybody's going to take the hit. So I want you to know that. I want you to understand the way that our caching works so you can be intelligent about how you do your deployments and when you make your changes. All right, not just code. Code is not the only change. Any metadata change is going to invalidate your org. Any package installation is going to cause an invalidation event. Any change to org state, turning permission on, turning preference on, These are things that are going to make us invalidate the cache. And you're probably thinking to yourself, why? Why are you doing so much invalidation? Why are you nuclear? Why are you just always wiping everything out? And it's a good question. And I've asked the same question myself because it would be great to be able to be really intelligent about it and be surgical and precise and say, oh, you turned on Service Cloud licenses. That means that these 5 triggers and these 15 Apex classes need to be invalidated, but the rest of the stuff is fine and we can just keep it cached. Figuring that out is very difficult. It probably would take longer than doing a recompilation process itself, and we'd probably get it wrong. So instead of trying to, monkey something together that would do that, we're conservative about it and say a change is made, and we have to say recompile the classes, the logic in your org. So any one of these changes, change to your metadata, deployment of metadata, deployment of Apex, installation of a package, same thing you'd say if you install a package, but what if no one's connected to it? What if no one's making a query against it? It's really too hard to tell. So any change to packages, also an org state. So keep these things in mind. But we are aware that this is not the ideal thing in the world, so we're doing some things to fix this. Now, I will say this. Generally, the process of on-demand recompilation works fine. One person has one transaction, goes a little slowly. They don't even notice it. Usually they'll attribute it to, butterfly flapping its wings on the internet somewhere and causing a thunderstorm on their machine. But there are some cases where compilation does take a long time, and it's a noticeable hit for the first user. And where if lots of users are using it, it can cause serious failures. It can cause major slowdowns to entire orgs. So we've been working towards some things if you've never had a conversation with me about this, it means you're not at that bleeding edge and you haven't run into this. There are people out there ahead of you on the canary and the coal mine trip that have found these things which have forced us down some of these paths. They're good paths, and we're happy that we're doing them. First one is we have a new process available that will compile the org and warm up your cache before we commit your deployment. So if you're to make a change to anything, metadata, Apex, rather than just saying everything's invalid, your deployment is now live, instead, we leave the cache valid while we're still doing a full compilation as part of the deployment request. And we'll fill that cache, at least the level 2 cache, before we apply the deployment and commit it to production. And that way, you still have to miss level 1 cache and go to level 2, but the compile step is anywhere from 3 to 5 times longer than the inflation step, so we're taking, 30 to a lot of the process out, 80% of it out. And a fraction, 3 plus 75% to, anyway. A lot of it comes out because we only are doing, you don't have to do the recompile, you just have to reinflate. So this process right here, we've been running this as a pilot. We're starting to roll it out everywhere. So soon all of your deployments, all of your package installs, all of your package upgrades will be doing this. So those ones won't cost as much to you. The only downside is that the deployment time will take a little bit longer. I don't know how long each of your orgs takes to compile. Maybe it takes 2 seconds, maybe it takes 2 minutes. But this is an asynchronous process. It's a headless process that no one's sitting there waiting for, so typically people haven't said a word about, well, my deployment's 35 seconds longer. So this will take a little bit extra time, but it's time saved by everybody else down the road. We have an additional option, which we are not yet rolling out everywhere, to do the same thing when changes are made to org state. So this is when I change a preference, where I turn chatter on in my org, or where I provision Service Cloud licenses for the first time, where I deprovision all of your Service Cloud licenses, so any triggers you have that touch entitlements are no longer valid, that sort of thing. This is different from deployment because this is a synchronous user transaction. So if you're an admin and you're in the UI, you click a button, you expect that that page is going to just return to you, and you expect that your change is going to be applied immediately. If you're in an org that has a very long, lengthy compile time, it's not going to return to you immediately. It's going to be a white screen, and people are going to wonder what's going on. So sometimes you get user interface timeouts if the compile is really long, and even shorter than that, you get user patience timeouts where people start refreshing the page. And we actually turned this on in some places, and people just did not like it. If you have a situation where a perm change in the middle of the day a preference change in the middle of the day is causing catastrophic failure, we can activate this. We can help users understand this is the thing that's happening when you make changes. But turning this on everywhere involves a significant behavioral change that we just can't blanket apply it. We'd like to make this asynchronous, but there's a lot to do. Either way, when you do deployments of metadata, when you do deployments of packaging, we have this new process that will compile before we commit. And if necessary, we're going to offer the same thing for changes to org shape. So those are the only ways that you end up with invalid cache. There's other things that happen, namely our maintenance windows. there's a bit of a gap between when the server turns off and when the server turns back on. And when you turn back on, there's nothing in there. There's no cache because it's all running in your memory. So whenever we restart the service, and whenever we do a maintenance upgrade, we actually are changing the underlying schema, we shut all our machines down and turn them back on, there is an invalidation event that happens. This one's totally not your fault. You didn't do anything about this, but we're still going to have that same process where we need to recompile everything. We need to repopulate those caches. So we are working again, since again this is nothing you can change, on ways to make that process as transparent as possible. I mentioned earlier that there was an additional copy of the bytecode stored in the database. So if you miss in the distributed cache pool, it wasn't there, because I restarted the app server and I just shut down the memory of that particular corner of the pool where your thing was, you don't have to recompile the class. If you haven't changed the class, we've got the bytecodes already stored, so we can just transfer those into the distributed cache and repopulate it as needed. So rather than forcing a recompile, we just copy a file from the database. So we're able to use the longevity of the database to help us deal with single application server restarts. I don't know exactly how often they happen, but they probably happen more often than you expect. And so every time they happen, instead of forcing a recompile, we no longer do that. We now just have a copy of it on hand. More interestingly, when we have to do an upgrade, we do have to clear the entirety of the cache. We are figuring out the orgs that take the most time to compile and the ones that are encountering the most contention when service starts back up or whatever time your particular instance starts back up. And we're fully compiling those org before we cut over to the new patch version. So this way, the on-demand process works great for some of the smaller orgs with the shorter compilation time, and they didn't even notice that the cache wasn't warm. But for the larger orgs that have been experiencing some issues with warming up the cache, we are taking care of those particular orgs. And that's the algorithm for that changes over time. Some days, we take the ones just for a large amount of time. Sometimes it's the ones that are causing different cases. But either way, we're fixing it such that those particular things are happening as much as possible, so that there's as little compilation after a restart as we can make happen. So different ways of warming up the cache to make sure that your process is good. So how does the cache work? I see you out there tenting your fingers like Montgomery Burns, thinking, now how am I going to make my stuff more cached? Don't do this. Do not try to figure this out. And the reason I say that is this. The level 2 cache never misses. You are never going to find a time where your code is not in the level 2 cache. It is larger than all of the stuff on any individual pod. It is always populated. We never kick anything out for capacity reasons. And the L1 cache up on the app servers has a 99% and more hit rate. So it's very rare that you will find a situation where you even need to inflate from the L2 cache. Remember, the L2, the inflation part is a third to a fifth the time of the compilation step. So it's a much shorter process anyway. So there's not much value in trying to figure out how can I warm this up, how can I make this better. So no need to go Rain Man and try to game the system and count cards. The size of the cache is sufficient that you should not need to do that. All right. New compiler. I want to talk about the new compiler. I've been promising to a lot of people that there would be a new compiler at some point in the future for the last couple of years. So I want to talk a bit about what it is and why we're doing it. So something you may have gathered from the previous slides is part of our rationale for doing this. A lot of the health of our system, the ability to run quickly and the ability to operate rapidly, relies on the compiler being fast and not taking forever. That slow line that was drawing on that one request where a bunch of other people came in, that slow line's got to be fast enough that that doesn't take place. So making the compilation process faster will help us with the on-demand compile. If it's faster, I can get more orgs into the number of orgs that we're going to compile when we do a restart. So all the things that we set up from a cache perspective to make your code operate quickly are going to benefit from a new, faster compilation process. So this is a trust initiative to make sure that we can continue to scale. We've scaled up to 30 billion transactions a month now, which is crazy. It grows a lot. You guys are writing amazing applications. You're doing wonderful things. And we need to scale. We need to be able to scale to that growth. So the new compiler is part of that process. So some of you may be thinking to yourself also, a compiler is easy to write. What do you mean 2 years, right? I did this in my freshman computer engineering class, or I did this since the start of your talk. I wrote a new compiler. So if you did, please see me afterwards. I have a job for you. it's not that simple. The old compiler is what it is based on how it was born and how it grew. Apex began life as a database triggering language. And we figured out that it could do more. It could be for UI controllers. It could be for asynchronous processing. It could be for remote actions, and so on and so forth. As such, it did start its life with, let's get a good grammar, let's get a good language definition. It was lots of things built on top of lots of things until it looked like a bit like this diagram here, which will eventually open a bottle of wine, in case you're wondering what that does. One of the principles that we have upheld forever is that we will not regress old code. Your code that exists and works today will continue to work tomorrow. It's a big thing. It's a big thing for how this company works. I'm still amazed to this day that the upgrade process is you go to sleep on Friday and you wake up on Saturday. Like there's no, I have to spend 3 months of doing all these tests to make sure it's so smooth compared to, if you just think about the number of versions, from the 22 versions of Apex we support right now, it's mind-boggling that we can do that still. I've been working with the team for years and I'm still kind of boggled by it, but we have to continue that to compilers. We have to make sure that all of the things that work today, the old compiler, are going to still work tomorrow. So from a product manager perspective, this is pretty easy. My acceptance criteria was it does what the old one does, and it's faster. That's really it. It wasn't like I had to draw diagrams or basically make me a compiler that does what the old one does exactly and is faster. It does all these things we need to do, but scales into the future. Sort of a sub-bullet point is it will allow us to do some new features, which I'll talk about later. But a lot of things that we've been wanting to do forever have been behind this, have been waiting behind this train, because having this new parsing and this new compilation process is what is going to enable us to add some of the features that I've been asking for years, that you've been asking for years. So how do you build a new compiler? The first thing you do is you go and set up a nice grammar, as if you were starting from scratch, clean, fresh, brand new language. You set up your parsing rules, you get everything going like your freshman class where you're building a compiler. It's really easy. And then you go in and you destroy everything you've done to carry all the baggage that you have to carry with you. And that's the part that has made this a very, very complicated project. If it were as simple as just, well, here's a new grammar, off you go. There are things and there are places where you can put extra text after your, like a dot, and it will just ignore that extra text. There are places where you should have to do explicit cast that you don't. We were just nice, so you don't have to do explicit cast there, right? That's just fine. We'll just assume we know what it means. You can have the same name for variables if you set them up just the wrong way. You can call two variables the same thing. I don't want any of you to try to figure out what these things are. I didn't put them on this slide intentionally because I knew some of you would, and the problem is we need to support everything that's out there. We need to support all the code that's out there. Everyone who got into these crazy states, we're going to have to support them. And so because it was built sort of, we just need to make a trigger language, some of the thoughts about explicit casting weren't, we didn't think about that at the beginning. This was long, long ago. And so now we have to make sure that we support some of those things. While we're going, we are trying to get rid of some of these. Some of them we found on our own, some of them we found on people's org, some of them we found in DE org, some of them we found in my DE org, and we said, oh, we could just ask Josh not to have that in his DE org anymore and we'll be fine. So we tried to find some of these little nuances, and if we can eliminate them without harming anyone's actual behavior, we are trying to get rid of it because we'd rather the car not have as much baggage on top of if we could. But we are going to continue to support everything, all the little craziness that's in the application. So how do we make sure that this is safe to release? Then we're done. How do we know that we met that first acceptance criteria? There's two acceptance criteria, that's the same, and then it's faster. We built something called a validating compiler. What the validating compiler does is it runs twice. It looks at a set of Apex code, and it runs with the old compiler, and it runs with the new compiler. First thing it does is it looks at the bytecode. The actual bytecode we're going to interpret and operate at runtime, make sure there's no differences between them. After that, it looks at other things that we save as part of the compilation process. We save references so that we can do some of our tool work. We can say this thing refers to that class, or this package refers to this thing. So we make sure that everything that's saved as a part of the compilation output is also the same. We can check performance. We make sure that whatever particular thing you did didn't send us on accidentally into an infinite loop in our code. That would be bad. So we check to make sure that each individual compilation process does not regress against the one from the old compiler. And every time it finds something where there is a difference or there is a performance regression, it logs bugs. And so there's a lot of iterating on this, of running this thing old new, looking at differences, finding bugs, trying it again, finding fewer bugs. A very long and involved process. We first ran this against our internal F-test suite. Our functional tests, there are 35,000-ish internal functional tests that have Apex code in them. And that was our first base of Apex that we ran this against to make sure that all the stuff that, oddly enough, some of the things in our functional tests that we wrote 6 or 7 years ago have some of the craziest of the crazy things that we support. So we're getting our internal folks to change their tests. But we found a lot of the old direct running against our internal tests. But the first set was us internally, making sure that our stuff works so that we would take the first lumps. We've run this against all of your orgs. And when I say all of your orgs, I mean all of them. Every sandbox, every DE org, everything. We will run it against an entire instance and check it on every single one and look at the results. And after doing some bug fixes, we'll do it again. Has anyone noticed? You guys noticed? You haven't noticed, right? So we do this in an asynchronous way. We've been able to do this so it hasn't impeded the performance of the rest of your application. We want to make sure that nothing that we're going to release is going to have any difference when we turn this on for your org. So we are not, as you can tell, being very look before you leap with activating this. Tom Brady can get away with jumping off a cliff without looking at the bottom, but we can't. You guys are our children. We have to make sure you're safe. We have to make sure that you're cared for. So we have taken great lengths to making sure the activation process is smooth. It's not something that we're just going to turn on at winter release or at spring release or at summer release. We're not going to do that because that's invariably going to cause some issues. We put a much more involved process into place. So rather than sometimes just flipping a permission, sometimes you can just flip permission, it turns it on for your particular customer org. We're doing much more than that. So we're going to use the validating compiler. We're going to set you up and say, I'd like to activate your org. That's going to spin up a process that's going to run the validating compiler with the old and the new, save the output. As I mentioned before, compare the bytecode output, compare all that stored output, and compare the performance, and log bugs anytime you get that. If you log bugs for any of those things, we're done. If and only if we pass all of these steps, identical bytecode output, identical stored output, and identical better performance, then we will enable the compiler for the org. So it's not a simple flip. We say, if you'd like to turn this on, go through all this, and then we can enable it. The nice benefit that the cache is already warm, right? Because the bytecode's the same. So all that caching stuff I talked about, you'll have no impact here. So at least this one, we won't have to redo the cache. Think about if you guys are anyone here in ISV, you're probably thinking to yourself, okay, that's very interesting. How are you going to work with this for me? Because I have to install, as you're doing this changeover, it's not going to be instant. So I'm going to have my package installed in some orgs that are on the new compiler. I'm going to have to install my package in some orgs that are on the old compiler, right? So I'm going to have to be in both places at once. How are you going to make sure that's good? It's a very good question. We've had a couple things we're set up. The first one's called VP mode 1, validate parse, VP1, validate parse 1. And we're running this for some period of time on all packaging orgs. Anyone that's released a managed package, we've been running this, and we check to make sure that there is no distinction between them. So we're going to run for some period of time without any problems, at which point we're going to say this thing runs identically with the old compiler and with the new compiler. Package orgs get to go first because of the fact that as we're doing this changeover, these are going to be installed in different orgs that are going to have dependencies on that package. While we're doing the cutover, called VP2 mode. VP2 mode is when every time you try to upload your package, we are going to do that same check again. We're going to check to make sure that whatever changes you made also continue to operate the same for the old and the new compiler. No difference whatsoever. We'll actually block an upload if that happens. The purpose of the VP1 stage is that we don't expect there to be any. We'll have run that for long enough, it'll have gone long enough that you won't have any issues when you get into the VP2 stage. But this way we can make sure that packages are going to be safe regardless of where they're installed. We're going to keep VP2 mode on throughout the entire activation process. So what's the order in which we're going to do this? Again, dependencies are important. Packages need to go first, for the reasons I've just described. But after that, who gets to go first? Who's volunteering their org to be the first one to go? The answer, of course, us. All of our internal orgs, our 62 org, which is our SFA org, our GUS, internal bug tracking system, the ID exchange org, the app exchange tracking org, our support org, our foundation, salesforce.org, all of those go first. So we are going to be the canary in the coal mine here. If there are any problems, they're going to hit us, and we're going to take care of them. So you can imagine we have extra incentive to make sure that when we start the rollout process, everything is good. I'm working on it and making sure that's true. After that, we're going to try DE orgs, the ones without packages installed, to make sure it's good, followed by the ones that do have packages installed, and then we go to sandbox, and then to production. Now, production orgs, there's even a subset of those that we're going to do absolutely last, because there are some customers who do not like any change in their org until everything is all good. But this is the general order. We're going to go first, and then we're going to do sort of smaller, easier orgs first, and we're going to roll forward through. And this is the way we're going to ensure that as we do this process, there aren't going to be any problems. So you might be thinking, so when am I going to go? Or have you already? It's possible. You do not know, and you're not supposed to know. That's the idea. We call this a dark launch, where we're doing this over time, and we're taking great pains, as the fact evidenced by this whole conversation here, of what it is that we've been doing to make sure that you won't notice. You won't notice a thing. And that should be largely true. All software is software. All software has bugs. There will be problems, but there are problems today that happen, and there will be problems with this as well. At some point, there aren't going to be problems with the new compiler. There's going to be problems with the language, with the platform, just like any other problem that you run into on rare occasion. But the idea is to minimize that and to go to great lengths, as I mentioned, to make sure that happens. So really, why did we do this? What was the whole purpose of this? And where do we get to go with it? So people have been patient for a long time. I've been patient wanting to release features for Apex. There aren't nearly as many things in the release notes as I would like there to be, because we've been working on this. There are things that I know you've all wanted forever, particularly getting a switch case statement. Modules where you can do this, that, application, Josh, cool stuff, class name. The way that the name resolution works in the old compiler is I'm trying to think of a polite word for it. Impossible to change easily to make it work like I just described. So that is something that's probably the biggest thing that we're going to get out of the compiler. Faster compilation, incremental compilation, so that when you're doing development exercises and you're saving things to the org, sometimes some of you run into 5-minute saves through the API. Those will go away because you're going to change just one file. We're only going to change the one file for you. So lots of features that we've been asking for forever. They're coming up. But they have to wait behind this big process. So it's big. It's massive, the compiler. It runs 30 billion transactions a month. And you guys keep writing new stuff. You keep writing great, clever, unexpected things with Apex. And we have to support that. And I want to encourage it. I want to make sure that what you're doing is getting you where you need to for your business and allowing you to build the logic you want to. And we're doing our best to make sure that we don't impede at any point in time what you're doing. And at the same time, enable us to go down this road with you of making it even easier in the future. So that is the whole story of the compiler, the new and the old. So thank you very much. If anyone has questions, there's a microphone right in the middle of the room. So you can walk up to the microphone and you can ask. And I may be able to answer.
So you're keeping a lot of legacy. Thank you. What about an Apex 2 or something where you don't have to worry about legacy?
It's been brought up. I think if I were to, I don't know. If we were going to have Apex 2, I would call it Java, and I would say run applications using Heroku and connect them into using external services and other functionality that we're doing. I don't know that there's
That's a good idea.
A need for an added language. And so people, Java bytecodes, we've talked about, could we just write Java code and compile it and run that? And yes, we could. The trouble is the nuance of like whether you round up or down on 0.5 and things like that. Like if it behaves just a little differently than what you expect Java to do, then it's worse than it not doing anything at all, right? Like the little differences are what drive you mad, and you can't. It's hard enough to test the whole of Apex. Try to test the whole of Java on top of it. We can't really do that and like effectively do it. So I would just say things that work in Apex, it's transactional, it's in the transaction, it's tied to our data model, it works with all the other parts of the logic in the system. There's great reasons to use Apex, but if you've got things that are outside that exist already, we have Heroku as part of the platform where you can run a credit scoring service and just call that thing. You don't need to port that whole thing in. So if you're looking at an Apex 2, I would say use Node or some other Scala, whatever language you want to use, and run it and connect it with Heroku.
Thank you.
Will one of the new features be that we have faster running Apex, like faster running triggers? Is that
Are they not fast enough for you? So they'll always
Sometimes not.
They'll always be slower because they're interpreted, as I described, right? Because we're not running them directly on the JVM. They're going to be slower because we have to keep you safe. The compiler is only working on the compilation part. It's not working on tweaks to the runtime. We do those from time to time for various reasons, and that may be one of the new projects we do is to, now that we spend so much time with the compiler, maybe look at optimizations there. Because it's not as fast as it could ever be. It's its own interpreter. It could always be improved. But that's not part of this project.
So my question is, if change set is already validated, so does it will again, when you do a quick deploy, it will compile again all the classes, or the quick deploy will take less time?
Quick deploy, meaning I run my tests and then I do a deployment later. Quick
so
deploy?
if you deploy any change set on production, you have deploy at that time, or you just validate, and if change set is validated, you just do a quick deploy at that
when you
time.
do the deployment, it's got to, that's the event. The actual committing of the deployment is the event that causes the invalidation to take place. As I said, that will, at some point in the very near future, that will no longer harm you because we will compile everything before we commit. But yeah, the quick deploy doesn't help you avoid cache invalidation.
Okay, thank you.
Yep.
Hey Josh, what's the oldest version we're still supporting?
Officially, I think we only support 3 years old, so officially it's like 29.
But you mentioned you're supporting 22.
There are
so
still things
that's-
running on version 15, I believe.
Okay.
I don't know if there's things older than that are running or not, but I know there are things in version 15, which is 22 version. This is why the 23 version is actually inclusive, right? But yes, a lot of versions.
Okay, and you said it was either 30 or 50 billion transactions. That's a month?
Yeah, 30 billion a month.
Don't we have some days over 5 billion?
I don't know. The stats
Yeah,
I looked at
usually
were
3 or 4, so I'm surprised that sounded like a no number, a low number.
it's just Apex, though. I'm talking about just Apex.
Okay.
Apex alone. Apex is not part of every single like if you go to the UI and you load your own
Gotcha,
page, you may
okay.
not run Apex, but actual Apex transactions themselves, 30 billion a day,
Okay,
a month.
thanks.
Hi. Is there any plans to publish the grammar?
There are plans to expose the grammar. Yeah, there are plans to. It's a much longer answer than that, but yes, there are plans to.
Okay, thanks.
Hey, I was wondering if you would ever consider a sort of a strict mode compilation flag or annotation so that you can run the compiler without having to backwards compatible to the old stuff.
Meaning?
Well, you've kind of optimized the new compiler for all the old crap.
Yeah.
Can you kind of forget about that with a flag or annotation?
Yeah, we've talked about that as well. I mean, ideally, if you are still working in an org and still fixing things, you should be upgrading to newer versions of Apex to make changes. That would be better for everybody for a variety of reasons. But there are lots of orgs that don't have anybody changing their code anymore. They had a consultant come in 4 years ago, and that guy is no longer even working in software, and they don't have anybody who knows how to make any changes to it. So we can't just force people up to the newest version in all cases.
No, I was thinking it would be something you would add to it with new code. You wouldn't have to touch the old stuff. It would be kind of an addition to new stuff, say, which would give you speed benefits and stuff.
Yeah, but until we have everything out, we can't take it out of the code base. We have to keep supporting it, so the code base is still littered with if. That's the trouble.
Fair enough.
Do the declarative tools, do those compile to bytecode as well behind the scenes, or are those totally a different animal?
Yeah, unfortunately not. I've tried to convince them that all of their logic could be expressed in Apex, and we would have one engine, but no, they each have their own different engines. A separate engine for process and for flow, even a separate engine for rendering Visualforce for Lightning. So there's lots of different engines we have. So no.
Thanks.
Hey Josh, thanks. Great presentation. So we've been seeing some compilation issues in like the last year or so, and I wonder if this sounds like it's part of the new compiler. So say we have like 10 dev orgs and a few QA sandboxes, and someone will check in and change where they change the name of a variable that's bound to the Visualforce page. But they also change it in the Visualforce page, so it should compile. And it'll compile in maybe like 8 of our orgs, but maybe 2 of them it won't. And the only way that we can fix it is they have to go in the Visualforce page, remove the reference, save that, and then they can do the full deployment, and it'll succeed. And I don't remember seeing anywhere on the boards that other people are reporting this, so I wanted to.
It sounds like it's more related to the references that we save, but I don't know
Yes,
exactly.
yes.
What?
Yes.
I missed that.
So they're all saying that they've seen it too.
Yeah, it
But-
sounds like it's a reference check. So we do save out some of our references separate from the actual compilation process. And that sounds like what's causing that, but I'd have to look into it. I don't know exactly. But I don't know if it's something that will be fixed or not, because I don't know the source of the problem.
No,
I can't-
we just saw it when we did in our packaging org right before Dreamforce, so it's still there.
Okay. I don't know the answer. Sorry, I don't know.
Okay, thanks.
So you talked earlier about this happening behind the scenes. Is there a way for us to check somewhere in our settings if we've actually been upgraded to the new compiler?
No.
So there's no way to know.
Nope.
Just for our own purposes, no?
You should just assume that whatever you're doing is working. We'll know if like a problem comes in, we'll know. When a support problem comes in, we'll be able to check, okay, what state is this in so that we can evaluate it. But the goal of all of this is to make this so there's no need to know when. It's going to only change when your org is perfectly equivalent both ways. That's the entire goal.
Do you have a date when everyone should be upgraded?
Maybe.
All right.
A very quick question. Will the new compiler allow us to have more than one namespace, local namespace?
Yeah, that's the goal, is to allow that modularization, so both for isolation purposes and for organization, so you can be able to say, I want to scope this down to this package, and I want to, structure my code in not one giant folder. It's coming with the new compiler once it's done. All right, I think we're at time. Thank you, folks. Enjoy the rest of the conference.